Azure SQL databases and managed instances come with a powerful performance monitoring feature called Query Store, and it is already enabled by default when you spin up your databases and instances. And now with the power of Azure and Log Analytics Workspace, you can capture information from multiple instances and databases in one Log Analytics Workspace and then centrally visualize and be able to dig deeper into any potential problems that you may have. I'm going to show you this feature on some managed instances that I have at the moment. So here I've got 3 instances. I'm just going to show one instance that I've got and the databases that I have here. And if I go into this database and diagnostic settings, you'll see that I've got a setting already available that is sending my metrics from Query Store, both the runtime statistics and the wait statistics, to a Log Analytics workspace of my choosing. This is something that you have to set up for every user database that you want to capture this information from on every single instance. So Query Store is a database specific monitoring tool rather than being instance specific. Once I've set this to capture for all of my databases, I can now use Log Analytics Workspace to do the rest. So if I go into Azure Monitor, and then I'm going to go into Workbooks and I'm going to create a new workbook. And the workbook that I'm going to get is from this blog here. So if I go into the Workbooks folder and select this one, Azure SQL Managed Instance at the bottom, and then go to the raw JSON text, copy all of that and paste and replace what is already in the window. Click Apply and then Done Editing. Once I have this ready to run, I can now save it within Azure and call it whatever I want. So I'll call this Managed Instance Workbook and put this wherever I like. So I'll put it into this resource group and in UK South. So that is now ready to open up whenever I need it to. So now it's available, I'm ready to actually do some monitoring with it. So I'm going to take it to around the last 4 hours. And I can set for the at the subscription level, the resource group level, or even the managed instance level. We can see all 3 of my instances are available, and it is capturing already the metrics for these instances. And we can see that one of my instances is running roughly around 90%, another one between 60-65, and the third one is around the 40% mark. And I've got metrics already set up here for CPU, IO requests, IO bytes read, and IO bytes written. Underneath that, I've got some metadata about each of my instances as well. And then when I click on one of these instances, it now allows me to drill down even further. So now I've got information about each of the databases on this instance. And then lower down, if you already have Query Store set up and sending information via diagnostic settings, you can now point to the Log Analytics workspace that is collecting that information. Once you've done that, you then start to see information from Query Store perspective. So now we've got the duration, the CPU, reads from memory and disk, writes to memory, query max used memory, log that's being used, and any wait time associated in your databases. So all of these are now at the database level rather than at the instance level. So if I scroll back up, and we'll take a look at this instance in particular, which is running around the 85 to 90% mark at the moment. So this instance, in fact, all 3 instances have got 4 vCores. So for around about an hour running, that's 60 minutes, times 4 vCores, which is 240 minutes, and then around that 90% mark, makes it around 216 minutes of CPU runtime. Now, it's not an exact science, but if we have a look at the CPU for both of our databases and just go to a specific point in time, so this is around about 3 p.m. And at this point, it mentions that for 1 hour of query store runtime, Console Sub Main 1 was 126 minutes of CPU time, and Console Sub Main 2 was around 94 minutes. That's about 220 minutes, which is very close to that 216 minutes average. So that's basically showing the CPU is matching with the metrics. It isn't always like that. It's not an exact science, but in this instance, it is a very good indicator and something that we can use to now drill down and see which database is the one that's carrying the most workload compared to the other. And we can see that both of them are taking up a lot of CPU, but Console Sub Main 1 seems to be the worst offender. So we're going to scroll further down and go into the details. And this table here shows us the overall statistics for this 4-hour period of duration, CPU, logical reads, and everything else. So I can now drill down further by picking the database of interest. And in terms of the CPU time, it's Console Sub Main 1, which is the most CPU. So if I click on Console Sub Main 1, I can now drill by query ID, and I can select which metric I want to drill down by and order by. So in terms of CPU time, by a long way, 416 minutes or 417 minutes out of 440 total, query ID 77 is by far the worst offender. And if I click onto this, it will give me all of the plans used in that hour, in which case, for this one, there is only one plan ID 11. But this gives me a great starting point to be able to find out exactly which query is causing the issue, so that I can then look at the query and the plan and see how I can improve performance. If I take a look at Console Sub Main 2, which is 320 minutes, I now see for this one, we've got query ID 305, which is using by far the most CPU time and also logical reads. So this one is the worst offending query. And again, if I click on that, we now get the query and the plan ID for this database as well. So that gives you a good monitoring tool so that you can have a look at your whole estate in terms of your instances, both managed instances and SQL databases, and actually find the query or queries that are causing the problem by different categories, such as the duration or reads from memory or reads from disk and so on, and drill all the way down to the query and plan, so that as soon as we touch our SQL instances themselves and actually log onto the server, we're already armed with enough information to know exactly where to start looking and what query to work with.